Welcome, everyone. I'm Brad White with SCS Consulting, and I am unfortunately not with you in person today. I'm stuck on the other side of the border up in Vancouver, but we've got a great panel to talk about decarbonization. And we started talking about this 2 years ago in Orlando at AHR, and at that time, our most progressive clients were talking about decarbonizing. We were doing some studies, but what we've seen in the last 2 years is just an explosion of interest among our clients and building owners in the topic of decarbonizing their buildings. And I would say more importantly, we're starting to see these projects actually happen. Especially in the last year, we've started to see some of our clients invest big dollars into decarbonizing their heating systems in their buildings. So the session today, we're trying to focus on existing buildings. And so when we're talking about decarbonizing existing buildings, really what we're talking about is operational carbon. So the carbon that comes from the energy use in the building, the electricity and the natural gas usage. New buildings are kind of their own thing. I would say arguably a more mature market when it comes to decarbonization, and embodied carbon is a thing. But just for today's discussion, we're going to stay focused on existing buildings because I think it's a topic that doesn't get nearly enough attention. And because we're talking about existing buildings that are already existing, really we're going to focus on that operational carbon and how do we eliminate that from a building. Now, there's a lot of drivers, a lot of reasons why all of a sudden we're seeing this explosion of investment. And a lot of it is to do with regulation. We're seeing jurisdictions like New York City, Boston, Vancouver start to regulate greenhouse gas emissions from buildings. And we're also seeing a lot of corporate owners who have their own corporate ESG goals. They may say, we've got very aggressive carbon reduction goals for their portfolio. Some of them as early as 2030. We've got a lot of clients that have 50% reduction targets by 2030. And they're starting to realize that 2030 is not that far away, and that they need to start replacing equipment today if they have any hope of meeting those goals. Now, along with the talk about decarbonization, you'll hear the term electrification thrown in alongside it. That's a path that a lot of jurisdictions are taking towards decarbonization. And really, this is really a focus on replacing the natural gas heating systems with largely electric heat pumps. But as you'll see, and I think Craig will talk at length about you can't necessarily just focus on the mechanical systems, and you really do need to look at the whole building approach, the envelope, all of the other aspects that are sort of key to the building science piece. So, and I guess the other thing is, why is this even part of the automated buildings lineup? So I think the reason we're talking about it here and in this venue is because I think one of the things that doesn't get enough appreciation in existing buildings is that a really strong, robust, well-functioning building automation system, in my opinion, it's absolutely essential to achieving decarbonization in your buildings. So not only am I trying to operate these existing buildings, because there's a lot of challenges when you start converting from gas systems to heat pumps. All of a sudden, you got to worry about flows and temperature issues that you never had to worry about before. That requires a really strong building automation system, but also in the design, using data to drive the design of these buildings, size your equipment, understand that new operation regime, and then also sort of after implementation, that proof of performance and monitoring and verification that a lot of jurisdictions are requiring, a lot of certification programs are starting to require this. So the building automation piece is really key to the whole life cycle of the transformation of these buildings to low carbon. So in this session today, really what we want to do is give you some practical tools and information that hopefully you'll be able to use to start to succeed in these kind of projects, and hopefully give you an idea of where some of your products and services may be able to offer value in this process in ways you may not have considered before. So we've got a great panel of experts today with lots of experience in low carbon buildings. So with that, I think I'll turn it over to Craig, who's going to moderate our discussion.
Thanks, Brad. Thanks for kicking us off. Hi, everyone. My name is Craig Stevenson. I'm with the Oris Group. We are a consultant consultancy firm that focuses on the intersection of building science and data science. So I'm here at a national conference talking about building science with a lot of people who know a lot about smart building infrastructure and data science. So what we bring to the discussion today for this panel is how do we get to those levels of building performance that's going to help us meet our climate change goals. You know, if you're familiar with New York City's legislation, Boston just adopted similar legislation that's sweeping across the country. So I'm board chair of the Passive House Network. It's an international organization of passive house practitioners. When you hear passive house, a lot of people think single family or residential. We're using passive house strategies in large, tall buildings. The third tallest building being built right now in Boston is a passive house. So these are going into tall buildings. It's actually much easier to do this envelope first strategy in larger buildings than it is in smaller buildings. So what we talk about is, you know, from a building science perspective, how do we get to a level of retrofit in an existing building that gives us the ability to offset with renewable strategies, right? That's talking about getting a 75% performance delta from the way the building used to perform. If you use an envelope first approach to do that, you're using what we refer to as the natural order sustainability. Treat your envelope first, thermal barrier and air barrier, balance your fenestration. Active second, that's where we look to decouple systems. We can use low flow systems because now all of a sudden our loads have been reduced so dramatically that systems that we would never consider in some of these big buildings, we're using them because they're so efficient. Renewables last. We want our PV array to be this big and not this big. So we do that by using an envelope first approach. And the reason why I'm here with the panel is we are experts in simulation. We can simulate in multiple platforms. We take that simulation and export it dynamically to match up the trended data. So on the projects that we're working on right now, we're giving actual context to the building owners who want to know, did I get what I paid for? Using historics only gets us so far. Using analytics, data science analytics only gets us so far. It's when we're using those simulations to determine whether or not we got what we paid for that changes the whole plan. So when you think about building science and you think about data science, building science, smart buildings are not necessarily high performing buildings. Passive house buildings are not necessarily smart buildings. They're not giving us the continuous feedback loops that we know to manage those buildings over the life cycle of that building for 50, 75 years. So with that, I'll be co-hosting today with Brad and walking through some subject matter here, and then we'll open it up for Q&A. So Rory, please introduce yourself.
Great stuff. Thanks, Craig. Are we okay? So yeah, my name is Rory Barnes. I'm with DLR Group. We're a large integrated architecture and engineering design firm. I'm based in Chicago. I grew up in Ireland, in case you're trying to place the accent. People usually look at me going, is he Canadian, is he Scottish, what is it? Irish. And so yeah, I'm super excited. You know, I think for the year ahead, I mean, clearly we're dealing with a lot of challenges, you know, economically, globally, everything, but it is an exciting time to be in our industry, there's no question about that. I think 2022 is going to be an inflection point for us as an industry, and it's going to, you know, in terms of innovation and technologies and momentum, and again, taking a conversation that's traditionally been in the back of house, like the boiler room, the chiller room, and taking it quite literally front of house with displays and smart building applications and increase in transparency and accountability in these data sets. And guess what, you know, regardless of which part of the industry you're in, whether it's design, you know, contracting, integrating, manufacturers, we need it all, everything, and you know, can't get enough of it. You know, so it's exciting for me. I think what I see as a big trend, Brad and Craig have mentioned a couple of them here already, but I see that the card or the stick. You know, I think we mentioned a few of the sticks already there with the, you know, places like New York with local law 97, where, you know, and what's important for me with that is less the long-term goal. Clearly that's important, but the fact that it's now they have near-term legislation for, okay, building owners now are going to owe multiple hundred thousands of dollars if they're not in line with that first step. Boston was mentioned as well, the building energy reduction and disclosure ordinance up there. So we're starting to see that trend. You know, most of the major metro areas in the States have a energy disclosure benchmarking ordinance, and now we're starting to see that, well, now some teeth in it. You know, you need to reduce, you need to get on this path. There's legislation in place. So that's the stick, which I feel like is getting big enough now that people are paying attention. You know, in terms of the car, you know, you have your rating systems, your lead system. Well, Reset is one that I know Craig really likes as well. And the reason we do like it is because, you know, we really need to get down to brass tacks here in terms of focusing on outcomes and how we measuring and verifying that we're on line with these, whether it's the legislation that's in place or the, you know, the building performance certifications that we're pursuing. So I think, again, Reset specifically is one that's 100% focused on outdoor air, which I think is going to be key in a key metric when we're on this aggressive path to energy reduction. We can't just, you know, easy to be net zero, carbon neutral if we just turn off all the lights and board up all the windows. But that's clearly not what we're doing. It's what we're in our, you know, we're in the game of designing and you know, constructing high-performing buildings. So I think that's you know, that's what's exciting for me at the moment, to see that we're actually, you know, it can be fuzzy. We're looking out into 2050. How do we, you know, how is it impacting us today in 2022? And I see things like that, you know, as I said, local loading sound with the penalties that are going to be coming in place in 2024 as a key key indicator, which is a massive opportunity, massive business opportunity for everyone in our industry.
Thanks, Rory. Paul?
Thank you, Craig.
You're on.
Okay, thanks. Everybody can hear me. Paul Maxmuck. I'm with Newcomb & Boyd, headquartered out of Atlanta. I am part of the intelligent building team and sustainability team that works on bringing all these different components together in a formalized design, doing retrofits and new construction. So one of the things that I want to touch on is when you look at going down this journey, how do you start, right? How many building owners are in here? Okay. Does anybody not have challenges integrating? Everybody's laughing. How many system integrators here? Okay. How many people have integration? No problem. Everything works great. Exactly. So what we do is we develop the specifications on communication protocols, the integration standards, the Div 25, the sustainability metrics that we're looking to achieve on the owner's behalf. We're basically the owner's rep, right? We bring that in, work with organizations like Craig and Rory, where we bring a full service solution. And then after that's complete, we go into the validation and commissioning phase and apply these tools and metrics to make sure that the data we are actually seeing is what we're desiring to see. So a lot of these things, you'll find that it's not an easy process. We'll get into a little more of the detail in a few minutes, but there's a lot of messed up stuff out there that doesn't work. And the reality is, to meet some of these metrics, we need to get everything operational, reporting accurately to be able to deliver clean data to there. So thanks, Craig.
Thanks, Paul. So Brad, I'm going to kick off the first question with you. You mentioned the clients in your intro, and I'd like you to talk about your experience in working with clients to identify, do they even want to decarbonize? There are legislative reasons why we're starting to address it. There are corporate SDGs, Sustainable Development Goals, that are forcing them to make better decisions in terms of performance of buildings. I mean, for those who don't know, buildings use 40% of the energy in the United States that's created. We're by far the biggest user of energy, and there's a ton of waste in the system, as any integrator will tell you. So Brad, can you talk for a second about talking to clients about decarbonization and getting them interested in the subject?
Sure. And I'd say, you know, job number one when approaching a client on this topic is to figure out where they're at already. Because I mean, we see a really wide range in sort of where our clients are kind of at in terms of their journey on the decarbonization path. I mean, we have some who have barely thought about it, and we have others that are well along the pathway of planning already and have already integrated it into their capital renewal plans, for example. So I think that's job number one, is to kind of suss out, you know, where that client is already, because it's a very, very different conversation depending on what they're trying to achieve, and also like why are they doing it. You know, do they have a specific portfolio goal in mind? Are they doing it because somebody told them to and they think it's a good idea? Do they have a legally mandated target that they need to hit? These are all kind of important questions. Are they going after a certain building certification? I mean, I've had, you know, that, and that even drives some of the technical discussion that we end up having. I mean, I recently had a conversation with someone with a building ownership, and their end goal was to achieve here in Canada, with our Canadian Green Building Council has a zero carbon building certification standard, and that requires zero combustion on site. So that drives the solution in a certain direction, and really you want to know that up front, because now we're thinking, okay, I can't rely on gas for backup at all, even, you know, renewable natural gas. That drives thinking about things like electrical capacity and all sorts of other important things, versus, you know, if a client is like, you know, I'd like to see a 50% reduction in carbon. Great, that's a very different goal in mind, and I think that initial discussion really sets the tone for everything you're going to talk about after. And then you start to get into things, you know, we, in a lot of cases, we've abandoned using traditional financial metrics for talking about these projects. We used to talk about, you know, net present value and simple paybacks, and in a lot of cases, it doesn't work for low carbon projects, because, you know, the operational costs may be the same or a little bit more, because electricity is usually a lot more expensive than natural gas. So we've actually introduced new metrics that frame everything around sort of a cost per ton of sort of offsets. Now we're comparing alternatives and sort of what's the most cost-effective way to get rid of that carbon. We're going to accept that we're probably going to have to pay more, but we're going to still look for the most cost-effective path versus trying to justify a positive business case or you know, a payback under 5 years. I mean, you can kind of forget about some of that stuff with, depending on the nature of the decarbonization project. So just understanding all of that as the big picture lets you know kind of how you want to talk about it.
Thanks, Brad. And I think that brings up something I always like to use to give people some context on what the heck we're talking about. We can build a building to code-based standards, which represents the worst building we're legally allowed to build, or we can build something to a high-performance standard. And the question becomes, what's that spectrum look like? How much performance can I get out of that building? Passive House as a building science will point you in the right direction to answer that question. And then from there, we have to start figuring out where, you know, how do we assemble the team? How do we start putting all this together? So let's assume, Rory, that Brad has convinced our clients that we all want to do something better than code, right? How do you set goals and targets to align the entire team? You know, we want to bring in our engineers and we want these guys to understand where we're going with this. How do you do that to convey this alignment around the entire project team?
You know, generally, we're doing a lot of energy master planning now, so conceptual planning on you know, existing campuses and school districts and whatnot. I would say on a specific single building project, I think working that into the commissioning process in the form of the, you know, getting those goals clearly stated at the start of a project. You know, this is our energy reduction goal, and we put it right into the OPR document and book it as part of the commissioning. That's as a key performance indicator that you're going to constantly check back through every design review and every design iteration and submittal reviews, and, you know, that's the most important document in the commissioning process. So applying performance metrics to that everyone agrees on up front, and we've talked through and we've simulated and we've agreed that this is achievable. How do we, you know, and what is the plan for how we're going to show it, prove it, you know, because I think too long as an industry we've relied on, I mean, Craig, you're well deep in the simulation world yourself, and Craig would be an expert who uses IES. They're one of the best software tools. We use the same platform. They're out on the show floor, go check them out. But that's the high end of that simulation market. You can game those energy models and have them tell you what you want at the end of the day. And, you know, now putting some teeth into that and having an actual proper plan for how you're going to measure and verify and validate the performance, and having everyone buy into it up front, and then at the end, successful outcome if we've achieved those evidence-based performance outcomes as opposed to just predictions that go into the wind.
Absolutely, and I know you and I have talked about this a lot, and when we started doing this work probably about 6 years ago in terms of building performance, we'd come on project teams and we'd see an owner's project requirements report and it's 30 pages deep and it's got a ton of theory in there. Well, that was great. The charrette felt fun. We walked away kind of charged and ready to do something, but there was no actionable items in that OPR. And what Rory's talking about here is he's talking about a metric-based OPR, right? This is the first time in the process we start talking about numbers, right? If we're talking zero energy, how are we getting there? What's my pre-renewable performance of that building? There's a number for that, kBTU per square foot per year. Then we start talking about air quality, and there's levels of air quality performance we can manage in those design processes. So what we've ended up doing is we created an OPR, it's one sheet. Now it's 11 by 17, but it's one sheet. It's not 20 pages. And we reference that in every single project meeting. And we make sure that we're talking about that because that's how the team stays aligned. Otherwise, what happens is people start reverting back to code, right? They go to what they know. They go to what's familiar to them and they start going back to code-based standards. Getting to zero energy is a whole building treatment. You have to address it differently if you're going after these aspirational goals. So Paul, we got our clients ready to go. Rory's just set all of our metric-based goals. How do you come on board? And we're still focusing around this design support, right? How do we start to use this in our design support?
So now the ball's passed, right? Now how do we get to a design and implementation standard to deliver all the information that's required to meet that owner's objective? So some of the things that we have to look at, obviously we're talking about existing buildings, there's existing infrastructure there, right? So we need to do some on-site assessments, identify, making sure that we have the right metering points to achieve the data metrics that we are going to need to have to meet those goals. We're going to need to look at the different systems, the mechanical systems. If it's a chiller plant, look at that, make sure we have the data available from the chiller plant. We need to make sure that we do a gap analysis and all the information is actually streaming on that network. And then we have to get into the control solutions to see if we can develop the control sequences that are required to deliver those metrics. So there's a lot of initial footwork to identify the existing conditions, and now we have to go and digest that and go into developing the specifications and requirements to deliver those objectives. And that's at the point where those specifications are built, the integration specifications are built, the data mapping strategy is built, the networking strategy is built, how we're going to deliver that networking infrastructure or use the owner's infrastructure. And then that's where it hands off to the GC to go out with the RFP to get into the different vendors required.
And this happens really early.
Yes.
So this idea of schematic development, design development, contract documents really kind of goes away in this process of how you do high performance buildings. We cannot afford to go through our normal design and get to the SD and say, okay, well, let's go check our energy model. Let's go check our control estimate. When you do that, you miss the opportunities to change the way you treat your building. So we're talking about an early schematic development. We're deep into the energy model. We're deep into control estimates, and we're doing it iteratively, right? Target R values for walls. Go ahead, Brad. Jump in.
I was going to say, I've got a real sort of practical example that came up in a project recently, what Paul was just talking about there. And it's this building that we're working on transforming over to zero carbon. And right now it's got big old gas boilers. It runs hot water at about 180 degrees. So one of the key part of that project is if we want to put a heat pump in that has a maximum output of about 150 degrees, are we going to be able to maintain the building on that temperature? And we like to run tests. So I actually want to run the building at 150 degrees in the winter, see what happens, collect feedback from that building automation system, see where the problem zones are, figure out how is the building going to actually cope with this. The problem number one is I still have pneumatic zone valves and all the heating systems. So you kind of go through the whole process. You realize, okay, that's the first thing I need to do to get this building. And that may not be obvious when you're kind of talking about zero carbon in the boardroom. But the first step on this journey for this building to zero carbon is an upgrade to the building automation system to eliminate pneumatic zone valves so that we can actually monitor and control the heating system properly.
And I'd like to add one more thing to that. You did address something else, pneumatic controls in the building, and is the equipment functional? Do you have damper issues where you're bringing outside air when the dampers are closed? Do you have valves that don't work? The pneumatic operator's bad on there. All those things need to be validated in the very beginning. So part of that design process is also going to incorporate a site assessment, identifying the risks to the project.
So connecting a couple dots again, OPR, metric-based. Design support, metric-based. They're coming back and telling us whether or not we met our goals. We're using the modeling simulation to do that, and we're doing it very early in the process. So as we start to convert from this building science, right, how do we design better buildings, especially in existing buildings, to get into how do we operate those buildings? It brings us into the smart building infrastructure discussion, right? So again, Rory, how does your firm and how do you guys start to identify those feedback loops that we want to give back to our clients? Because we know our clients want to invest in better buildings. They don't have a problem, for the most part, investing in that. And we don't even argue that that's a premium all the time. Sometimes it's just better design for par. But how do we give them the feedback loops to tell them whether or not they got what they paid for?
I think it all comes down to data at the end of the day, because we need data to justify capital investment in the first place. We need data to, even like talking about deep dive, again, our operations focused expert, we use IES in the design phase and as part of the measurement verification process as well. But our deep integration with something like a SkySpark is a tool that we use extensively, and that's getting deep into the weeds on every valve and damper and actuator in the building. But honestly, it's just like James Dice, he has a great podcast. If you should check it out if you haven't already. But he has a great diagram, the hierarchy of needs. And it's just basically clearly we're here. We're talking about decarbonization. We're talking about 2050. We're talking about fuzzy mat out in the future. But you got to get on the path somewhere. And we're again, a lot of the reference points I'm talking about here are from working with the super well-known computer manufacturers in California, and but a ton of our business is just K-12 school district in the west burbs of Chicago, right? And so there's different needs there. And so when we're on this path, are you even tracking utility bills? Do you have an energy management system? Let's get that. How what kind of condition is your building automation system in? How do we improve that foundation so we can build on it? How do we get data from that building automation system and lighting control system, energy meters? Now we're starting to roll, but you need to start somewhere. And so I think our focus as a design firm. Again, a lot of our output firm-wide would be new construction. My team, I do the smart building practice at DLR, so a lot of our focus is specifically on existing buildings. But I'd still say it's coming down to verifying and validating that data, and just put some real metrics to it. I think the new construction is more developed, to Brad's point, but I just think, again, I've worked on so many LEED Platinum buildings 4 years after opening and brought back into retro commissioning and tried to do some monitoring based commissioning by integrating SkySpark to the building automation to try and harvest that data, and it's a nightmare. Every building's different, every building's a snowflake. We need to standardize some of that. I don't know, Paul, if you've been I just well experienced in that area too.
I just would like to say, touching your point, start with your benchmark data. Aggregate that data. You have to have a starting point, right? It doesn't mean anything if you don't have a starting point, because that's where your true value is going to be at. You're going to say, okay, here's where I was at. Now we came in and implemented this plan. We fixed the mechanical issues. We put on the new controls. We ran the new sequences. We're doing our simulation, and we're modeling that data now as it actually streams. So now we can show value on that return on that investment to the building owner, the developers, everybody, the investors that are involved with that. There's a lot of ESG money out there, but there's a lot of performance criteria that has to be publicly posted by these corporations that will use that money. So starting with a good plan, onward, managing it, and then making sure you have retro commissioning at the end there. That's a very important factor to achieve those goals continually.
So I've been on a lot of project teams where, you want to talk about a smart building infrastructure or emission verification systems with an engineer, and they get really excited. Next thing you know, you've got meters on every outlet in your building, and you're spending $3 million on a emission verification system that's giving you data that maybe doesn't meet with your OPR or the goals and targets that have been established for the project. So Paul, can you talk for a minute about how you get into operational technology programming and identifying what meters and sensors that the building needs to have to give us that feedback loop?
Absolutely. Obviously, we do evaluation of the largest consumers, right? We know the chiller plants are going to be the largest consumers. Lighting, if they're still not converted to LED, there's ways of streaming that data from lighting control systems if they have advanced systems. We look at data sources. Where can we aggregate that data from and move it across our software platform and bring it into the metrics? So we'll look at the key loads in the building. If there's, in some cases, they're mixed use buildings, could be manufacturing on one side, administrative on the other. There's a lot of different ways of putting that formula together. But it's really identifying the key loads in the building, which is similar to what you're doing with your LEED certification anyway, and you sub-meter those devices. You don't have to put 100,000 meters in the building. You can probably get by, at bare minimum in a multi-tenant building, a meter per floor, and at least identify where the consumption's going.
I'll say we've been able to get very creative with virtual metering too. You'll find that you've actually got a lot of the information in your standard building automation system, and then maybe you need to bring in you look up a balancing report and bring in a pump flow or something like that, and you leverage existing temperature sensors. We do that all the time when we're trying to work with kind of legacy building automation technology to see what we can get out of the data that's already present in the building. And we find, and I agree with you totally, like directly metering major loads, I think is something we would always recommend as well. But for some of those secondary loads, we really look to virtual meters. So you take temperatures and flows and some of the values you're taking from the building automation system. Some of it you're looking up in a manual, and you're kind of piecing that together, or you're taking like an amperage status sensor and looking up the nameplate voltage, and you get creative with some of that data, but you can actually, in a lot of cases, it's good enough to do what you want to do with it, to at least give you the information that you need to kind of move forward on the project.
Yeah, that's a great point, Brad. And, let's not forget, we need that data to make better decisions, as we all kind of talked about. I want that hourly data so that I can calibrate my model. Once my model gets to a higher level of calibration, then I can use it to create what if scenarios for our energy efficiency means. But Rory, I'd like you to touch base for a second on the building occupant experience. How many times have we been in buildings where people are shutting stuff off in an effort for decarbonization, right? They shut off their ventilation systems. Maybe they start shutting off different lights in schools. I've seen it in K through 12 where students are trying to learn and they're in an environment that they don't have adequate lighting. So, this is like 1970s, right? Sacrifice for conservation. We don't have to do that today. The technology exists to make sure that the building occupants have the highest level of indoor environmental and air quality without sacrificing that just to get to a decarbonization strategy. Can you talk that for a second?
Yeah, absolutely. I think that's, probably the elephant in the room with this whole conversation is, how do you stay on these aggressive carbon reduction goals? And, and clearly pandemic has thrown another spin on that with increased expectations for occupant comfort, health and well-being in the workplace. It was always a thing, right? Again, Dr. Joe Allen at Harvard, if you've not read his book, Healthy Buildings, check it out. But it was written before the pandemic, but all of the information in there is super relevant. And it's, I think maybe prior to March 2020, the focus was more on worker productivity and well-being and, that whole 30-300 rule that I can't say my trees, so I think it just makes fun of me, but you can say that this whole conversation, we're talking about the $3 piece, right? Saving energy. The $30 piece was how much corporate office space typically spends on rent-ish, and the 300 is all of your, the compensation for your people, right? You're paying, so again, in places like Vegas, we've kind of seen that where they've been progressive with pumping fresh air into the casino to keep people awake and pump money into the slot machines. Same thing in New York, Wall Street, keep everyone sharp and productive. But now, yes, clearly there's very high expectations for, I want to kind of know what the air quality is in my office. And chief engineers, facility managers are in this kind of catch-22 right now, where they're unsure of, they've got these energy reduction targets, that's clear, and legislation is written, and some, as we mentioned, in New York and Boston, etc. So they have to do that. People are coming back, and they don't. It's variable occupancy in these buildings. People are on hybrid schedules, and doing different shifts. It's not your 9 to 5 anymore, and so the concept of most people are, wait, our HVAC system shut down at 6 p.m. I didn't know that. I've never stayed here that late before, but yeah, that's what's in the lease. And trying to balance these air quality metrics, the move towards, again, we mentioned reset a couple of times, but that essentially, you could summarize that as a air quality monitoring standards, a data standard that's focused. And so I think, again, walk the floor out there and you'll see plenty of air quality monitoring devices and platforms. And yeah, it's no longer good enough for a design firm to say, hey, we designed to ASHRAE 62.1, the minimal acceptable performance standard. That's not, again, to Craig's point, that's not a high performance building. That's the minimally acceptable standard. Clearly, we're in the business of providing something more than minimally acceptable, and with these increased expectations. So yeah, just everything points towards the data and outcomes, and you can't, again, reset is so simple because you either meet the thresholds and stay below that benchmark and you're certified, or you don't and you're not. There's no other policies and protocols and promises to do X, Y, Z. It's just, here's the CO2 levels you need to adhere to. Did you do it for X amount of the occupied hours? Yes, you're certified. No, you're not. So I think we need to get to that level of simplicity to move this conversation forward.
Yeah, Paul, I'm interested to hear your thoughts on the same thing, because again, we're talking about metrics. This is an evidence-based approach. We set our goals with metrics. We're designing using those metrics, and now we're talking about operating those buildings.
Absolutely. So I'd like to touch on the IQ data, right? There are 81 people that are certified, reset certified in the world. I am proud to say 4 of them are on our team. So we take it very seriously. And I'll just use an example right now. In this room, fluorescent tubes, right? How old school is that, right? That there's huge energy consumption there. How many people have been listening to that VAV box cycle? How many people looked on the wall to see where the CO2 monitor is? Okay, these are the points I'm bringing up. So strategies and approaches that we would look at for changing control sequences, incorporate those types of technologies. We integrate that into the platform and then be able to report that data and metrics out to the centralized platform for the owner to see what results they're actually happening. And then when you notice how many people were in this room and the room opened up and people came in and people left, we really should focus on the load in the room as well. I mean, it's not just the mechanical system, it's also the people load, right? Your lighting load, people load, that's the load. That's going to vary. Maybe we change the programming sequence where we're not cycling that VAV box, more of a stabilized approach with that sequence when it is occupied like this, and back up that strategy slightly when the room starts to change with the occupancy level and the time they're in the space. Those are kind of things that we look at in objectives.
Absolutely, and we can do all that work in the simulated environment too, right? We can identify our lags for turn on and turn off, and that's an energy efficiency measure, as opposed to basically getting in a building and start going like this with a stat, right? I mean, that poking and hoping, the technology exists today that we don't have to poke and hope. We can literally use, a professional approach to identifying how to set a building up right and make sure it is set up right.
Our goal is to keep your operators out of there overriding things. Let the building get it right the first time, let it do its thing, study the data, then make your decisions on what you need to adjust based on what the data is telling you. The data doesn't lie. If it's there, it doesn't lie.
Thanks, Paul. So, Brad, there's one more really important subject I want to talk to you about before we open it up for Q&A, and that's this concept of low carbon capital planning, right? And I conveniently refer to that as triggers and sequences, because we have an existing building and we want to transform that existing building. How many of our clients can afford to go and spend $20 million to completely transform a building? What other strategies would you advocate and have you used to help them implement a plan?
So, I mean, the best time to be talking about low carbon low carbon planning with an owner is when they have already made the decision that they need to replace a major piece of equipment. So they've already got a boiler. I don't have a hope of convincing an owner to replace a brand new boiler with a heat pump, nor would I try. I mean, that's they've just spent a bunch of money on a new piece of equipment. The last thing they want to hear is, you got to get rid of this thing and do something better, right? So you're looking for that equipment it's already planned to be replaced and it's reaching its end of life, and then we're talking about incrementals. Then we're talking about, okay, well, if we did this is kind of business as usual, and now we're talking about this instead. We've had a lot of success too, and this is kind of probably something that's a little more peculiar to the Pacific Northwest climate, is a lot of our buildings still don't have cooling in it. But with the recent heat waves, a lot of our owners are reconsidering that. And so they're looking at adding cooling, and that is the perfect time to say, hey, if you're adding cooling, I want you to think about making that a heat pump for a relatively small additional amount of money, and you can get yourself halfway to decarbonizing your building at the same time that you're providing enhanced comfort by way of this additional cooling that you're adding. So we look for opportunities like that, because that makes the conversation go way easier, because they're kind of already in the mindset that we're going to spend a bunch of money. Then we're just talking about, okay, well, different options that they can consider. And I think when they see some of the greenhouse gas reductions that can be achieved through these incremental investments, we find a lot of owners are quite receptive to that. I think the other danger is you got to get them thinking about this early, because in a lot of cases, the sustainability department may have all these goals around decarbonization, but you've got the operations department and they've got a rooftop unit that just broke down. They're going to go buy the same rooftop unit that they've always bought, because that's what's available, and they're familiar with it, and that's what's easy. If you haven't already done the pre-planning to say, no, we've got this new equipment standard, and it is a heat pump rooftop unit, or even a hybrid rooftop unit that's gas and electric. If you haven't sort of thought about that ahead of time, you're going to miss that. You're going to miss that opportunity. And once that new piece of equipment goes in, it's 10 or 15 years before you can have that discussion again. And I guess the final piece is to look for other opportunities. And this is, again, very much what you've been talking about, Craig. But, you find out, hey, they've also got a roof replacement planned for next year, in addition to a boiler replacement. Now we can talk about, have a whole different conversation around levels of insulation, and starting to say, okay, the trade-off between improving the envelope, downsizing mechanical equipment. You want to kind of be aware of what's happening in the building. But if you haven't had those discussions and you haven't asked them about their capital plan for the next 5 years, you'll miss some of those opportunities. And there may be something they're not even thinking about, because it's 2 or 3 years out. But you can actually make a really, really compelling argument for them to bring that piece forward, because it helps achieve this other goal. Bring that roof replacement or that window replacement forward a couple of years, because if we do that, your boiler has to be half the size, your heat pump has to be half the size, and people get really excited and respond really well to that kind of conversation we've had.
Yeah, and I think we can all agree, plan for your building holistically, right? You have to understand in 5 years, 10 years, what is this building transformation going to look like? It's okay to do incremental execution. It's not okay to do incremental planning. When you do incremental planning, you miss those opportunities, Brad, that you're talking about. And replacing things in kind and expecting a different result is the definition of insanity. So we have to do our jobs better. So with that, Paul?
I just was going to say, aligning your strategic master plan, right, and how you're going to achieve the goals. Making sure all the right people are at the table, not just the operations team, not just sustainability. Everybody needs to be there, including IT.
Absolutely. That's a subject for other
discussion. That's this afternoon session.
With that, I'd love to open up questions to the audience and answer any questions you may have. Yeah, do you want to wait for the mic? Because I think we're recording, right? Yeah, we got one in the back of the room there.
Keep your hand up.
Thank you. Regarding the data collection and the modeling, is there a specific software that you could recommend that you would use?
Yeah, so on the data collection, I'll probably defer to one of my engineers. And then the software, on the software side of it, you know, you want to use whole building simulation software to do this. The common ones that we see all the time is going to be an IESVE. They're literally the best in the business at what they do. We can simulate everything in that building if it's energy related and light and, you know, CFDs. eQuest and Energy Plus are also capable. We've seen those programs. There are others out there that are similar, but those are the three main ones we see. On the data collection, Paul, start.
Data collection, my favorite topic. There are a lot of vendors out there. Our recommendation as a whole would be keep your system to an open architecture that will allow any manufacturer to aggregate that data and roll it up to your software platform. I'm not going to mention any manufacturers' names. I don't endorse anybody. I look at what the requirements are and give opportunities of manufacturers that meet those requirements. And that field is changing all the time. And I just would also put out there, make sure you understand what those product roadmaps are to make sure you're going to be able to pivot as the technologies evolve and communication protocols and different sensor technologies evolve. We'll be able to ingest data into other sources that we can't now, or just starting to be able to do that. Did I answer your question?
I have a question maybe for Paul as well.
I can't take a question from you, sorry.
Or anybody else. Around you mentioned people using load within spaces like people counting. I was curious, is there a certain technology that you typically specify? I mean, I know there's some like brands out there that do people counting at the door. I'm just kind of curious your thoughts around what you typically specify for that.
Each space type is different use case, right? If we just want to get a total count, trip counts work well. If you want to work in an environment where you know how long people are going to be in that space and do control logic sequences, now we need to go to more of an advanced technology, maybe an imaging type of sensor or low, you know, a LiDAR or something similar to that we can get better granularity of the people in the place and distinguish what's person, what's equipment, right?
Maybe add to that briefly. I think it's important to know what your outcome is for that people counting. I mean, is it to adjust an outdoor air damper to optimize ventilation, or is it, we recently deployed across our entire portfolio a tech client that was super interested in learning what they designed, how did it turn out? And you could probably simply summarize that as, you know, we've got an extra large conference room, a medium conference room, small conference room, a bunch of phone rooms and breakout spaces. They just want to know, was that design layout, how is that workplace utilized? How are people, how are they working? And so you start to open up some of the questions of personally identifiable information. So, you know, if you look at, you know, again, not endorsing any of these because they're all the bleeding edge of this, but they're companies like Density or VergeSense, they've exploded since March 2020. And because people want to know how spaces are being utilized, people want to do smart cleaning policies, you know, so if people didn't utilize that conference room, we literally have a heat map of where people were all day, right? So that's one of the biggest growth areas I've seen, is just those people counting and motion tracking. So, yeah.
I was going more for what you said initially around, like, if it's like a fitness center or if it's a conference room, you're going to modulate the outside air based upon how many people you have in the space.
Yeah, so the more advanced the sensor, the MQTT protocol that they stream up to their cloud allows a API integration in there where you can pull that data back down into your database through a webhooks or whatever. So again, it depends on the use case. It depends also on the policy of the organization. Some policies, what we apply in the US, may not be the same policy that would be in Europe or other countries, right? Each region's different, and there's different governing authorities for your personal identifiable information. So that's part of the process, vetting it out, making sure there is not an issue with that. There's no way of identifying people, no way of tracking people, and that's why some technology solutions could potentially violate that policy. You know, such as something picking up off the Wi-Fi signal or whatever. So it's different for every case, but yes, is it capable of doing those things? Yes. Is it capable of integrating with the lighting controls? Yes, if you have the right system spec and integration platform there.
We still have a few minutes if there's more questions, please.
What's the major advantage over that technology versus, say, CO2 and NOx sensors? So I'm just trying to look at it. What I'm missing.
Okay, CO2 sensor. What does that give you? CO2 reading, right? The IAQ sensors are also measuring particulate in the airstream. They're measuring VOCs. They do temperature, humidity, and some add some additional toxicities in the environment that can be brought forward depending on how advanced it is.
So reset air, we talked about that a few times. It requires that we monitor 6 parameters of air: temperature, humidity, CO2, TVOC, total volatile organic compounds, and PM2, 5, and 10. They don't really do 10, but you really can't buy a reset air sensor without PM10.
Yeah.
There are monitors hitting the market, especially in China, where they're starting to put all kinds of sensors in there. So we're seeing, acoustic sensors, light sensors, and it's starting to become a lot more robust. But right now, you can pick up a reset air monitor for what? We're about $400 bucks.
Well, yeah, between $400 and $600. But yeah, you got it. I mean, there's a $40 sensor and a $400 sensor.
Right.
And I would argue, when was the last time that CO2 sensor in this room was calibrated? If there's even a calibration protocol for that sensor, there's probably not, right? And so, again, having a standard that says, all right, here's the threshold. It's a hardware standard as well. So you need to have a protocol for recalibrating and whatnot.
And that this is where the integration component comes into bear too, because if I have a CO2 monitor that's solving for my reset air certification, I can use it in my BAS system and I don't have to do duplication. So there's a lot of that integration that goes on. If OPR is built right, that's where you can get at those efficiencies. Chris?
I would like to know your opinions on predictive versus reactive controls. So in other words, tying in the weather, predicted weather data, predicted humidity, predicted grid cleanliness, and then having your building respond kind of in anticipation of those feeds.
Brad, do you have a perspective on that?
Yeah, I mean, we use that stuff. I would say use it very carefully, and we use it very very conservatively, because I think what we've found is that I think until, at least with the traditional building automation system, traditional sequence of operations, you need to be careful, because I mean, we've encountered all kinds of comfort complaints if you are too aggressive in how you're using some of these predictive tools. I think what I've seen, though, and the trend I'm seeing, is as we start to incorporate machine learning that make, I think, sort of traditional sequences into something that's more adaptable and flexible, that can respond better to changing conditions. I actually think we'll be able to do a lot more and a lot more effectively at that, because it will, machine learning algorithm will be able to take into account the multitude of variables that you would need to consider to do that properly. Whereas with traditional sequence of operations, 2 or 3 variables is kind of all we can look at before the complexity kind of gets too much for any one operator to manage. And with that, I think that's why you're forced to be conservative. So I see a really bright future for that. I think right now we use it, but in a very limited and conservative way.
You're welcome. We have time for another question.
I'm pretty loud anyways.
Well, we're recording, so
Okay.
just hang on for half a sec. Thank you. There you go.
So I've noticed that a lot of people ignore facades as a whole, and you guys were talking about building envelopes and how you can make them tighter. So I was hoping that you could just expand on that, because everyone always looks at mechanicals, doing 1-for-1 swap, or just looking at ways to take what's already existing and reposition it to decarbonization.
Yeah, I mean, if you look at what they're doing in Europe right now, and Europe is leading the world in terms of building efficiencies, they're killing the United States. Canada is far, in my opinion, far in excess of where we're at in terms of building efficiencies. We're America, we just don't care, energy's cheap. They're removing facades in Europe right now. They're ripping down facades and putting them back up. What we see in the United States is a lot more either inside out or an outside in retrofit, where we're treating that wall for thermal and air barriers either on the inside or the outside. There's a firm out there called Energy Sprong, and they started in Europe, and the Rocky Mountain Institute brought them to the United States through an investment they've set up in California. We're starting to see a lot of that retrofit now happening. For the most part, what you're seeing in our, at least in the normal American projects, is you're seeing fenestration treatment. So a lot of glass and glazing and doors, you see those retrofit all the time. We are advocating, and we're on a few retrofit projects that are going all the way to the passive house standard. It's called an Interfit standard, and they're touching those, but it's much more common in Europe, and I think it's coming. The carbon laws that exist in New York City and Boston and that are sweeping across the country right now, they are requiring buildings over 50,000 square feet to reduce carbon by 40% by 2030 and 80% by 2050. You cannot reach those levels without touching your envelope. You can't get there. So we're seeing it, and it's coming on rapidly. Is there anyone else who'd like to add to that?
You covered that pretty well. That's
You did a great job.
Yeah. That's great, to be honest.
The only thing I would add on that is I think when we're looking at these projects, it's very climate dependent. I mean, I agree that, getting those deep reductions, you almost always need to look at the envelope. The business case around the envelope and the importance of the envelope we see is really tied to the climate conditions that the building experiences. I think the more moderate the climate, I'd say the importance of the envelope doesn't go away, but it's less important in Central California than it is in Minnesota, for example, or Canada, parts of Canada anyway. So I think in this, I'm really just advocating it is a kind of a building by building approach, and you do need to understand the particulars of the building that you're looking at, especially when it comes to existing buildings. And the other thing is you may not even know what's in the existing envelope. And that's why we like to do some real-time tests, like change the operation characteristics of the building, see what happens, because you'll find out, no, wait a minute, even though it was spec to be this kind of level of insulation, they actually forgot it in that section of the building, and they've just been pumping heat into that zone to cover that up for 20 years. Those are the sorts of things you'll run into in existing buildings. I think make existing buildings kind of interesting, but also more challenging. And it's you really want to actually run the test, and you find out that, hey, wait a minute, in that case, I need to pay particular attention to that zone. The rest of the building may be fine. I need to target that particular part of the building for an envelope retrofit or rehabilitation, whatever the case may be.
So I think it's important to note also, Brad, that when Passive House was created in the 70s by Wolfgang Feist out of Germany, the reason why they created it was thermal comfort. That's the problems they were having and they wanted to solve. And they found out really, really quickly, if I treat the envelope from a building science perspective, I get at energy and I get at indoor air quality and thermal comfort. And that's why the standard was actually created. So it's solving multiple problems. Yeah. But yeah.
Greg, I think there's a question over there.
Yes, sir.
Yeah. How much?
Hang on. Thanks.
How much effort or investment being done towards making the power plants, fossil fuel power plants, and decarbonizing them? Because that's about 60% of the total energy production in the United States, right?
Yeah, Brad or Paul, did you want to?
I can add to that. I'm currently working on a project that's the end goal, eliminate it, right? They're looking at ground source heat pumps for providing that to the campus. It's a higher ed facility, and there is no natural gas there. They're running on number 6 heating oil to power up that plant and deliver power in there. So they've made adaptive changes in their master plan to do that. So their goal is to eliminate that and be carbon neutral here. So.
But there's a relationship there I want to touch base on too, because we're involved in community projects. This is no longer existing, more new. When you get in the community-based projects, that natural order sustainability still applies. Efficiency over grid, right? So when we go into those communities and we see our engineers planning for their grid deployment, their microgrids and their renewable strategies, assuming that the buildings are built to code-day standards. Well, I just over-invested in my grid, right? If I'm going to build a building to passive house standards or a 14 EUI, then should I not match and make that grid size appropriate so I don't overspend that and take that money that we just saved there and we can put it back into building efficiency? So this idea of managing your grid with the efficiencies of building absolutely makes sense. It's logical, but there's so many projects that just don't know how to do that yet. But the technology exists. The IES can do CIM, community information modeling. We do that all the time. And that's where we can start to plan for our grid. Taking advantage, to Brad's point, what if I'm doing a grid, microgrid replacement? I'm looking for district energy, right? That's the time I want to have the efficiency conversation, because I don't want to overspend on my grid. I don't know if that completely answers your question with regard to the power plants, but that grid is really an important factor in building efficiency.
I mean, I'll say the other thing is, most utilities offer an option now to pay a premium for renewably produced electricity. I mean, that's a really common thing that you can, I went through a process a few years ago checking a number of utilities, and most offer that option. I think if that is part of your decarbonization strategy, obviously you need to consider that, your source of your grid energy. And if you're paying that premium, I think as more and more buildings sign on for renewable electricity premiums, that demand is going to drive some of that transformation as well. In addition to regulatory mandates, and we see a lot of states and a lot of provinces here in Canada are from a provincial state level requiring the grid to clean up as well. So.
Yep, thanks, Brad. With that, our time is up. I want to thank the panelists for speaking today. Great job.